Form the pair of linear equation and then solve it by elimination method. A lending library has a fixed charge for the first 3 days, okay, and an additional charge for each day thereafter, okay. Sarita paid rupees 25 for 7 days, while Susie paid, I am pronouncing it right, I guess. If not, please don't mind. Rupees 24, 21 for the book she kept for 5 days. Find the fixed charges and the charges for each extra day. So the whole idea is this. We have these other days, like say you borrow the book, day 1, day 2, day 3, day 4, day 5, so on and so forth. So what they're telling is, no matter what, for the first 3 days, the amount is fixed. Like say 20 bucks. Okay, 20 rupees. That is, if you keep it for 1, 2, or 3 days, you have to pay 20. Suppose that you will have to pay 3 or 4 rupees per day. Okay, that is, each day you're paying, like say 5, 5, 5, 5, something like this. If you keep it for 5 days, you'll be paying 30 bucks. Till sixth day, you'll be paying 30, 35, right? Seventh day, you're paying 40. Something like this. So this is your fixed charge and this is the charges per day. So this is the idea. It is similar to your cab wala scenario in a different approach, right? There it was like, okay, it's a bit different, but yeah, if not, the idea is the same. Charges for fixed, okay, this is fixed and by default you have to pay no matter what. And depending on the distance, you'll pay the extra bucks, right? It's similar to that. So now we have two person. They borrowed different amount at different point of time. Sorry, different books at different point of time and kept it for different days. So 27 for 7 days and 21 for 5 days. Okay. So now we are looking at, let X and Y be the charges, be the charge, be the, okay, this we need to be careful with. Find the fixed charge and the charges each extra day. Let X and Y be the fixed charge and the charge for each extra day respectively. Okay. So X is for fixed charge, that is for first 3 days, the amount is fixed and that is X. And after that, each day you are charging Y, 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 and so on and so forth. So now, keeping this in mind, can you write the equation? It's not too hard. A person is keeping for 7 days and they're paying 27. Charges for 7 days is 27. So I'll write 7 days as 3 plus 4 because 3 days it's fixed and next 4 days it's a different amount altogether per day. So the charges for first 3 days is X, while for next 4 days will be 4 into Y. This is equal to 27 and that's my equation 1. 1x, right? Next we are looking at charges of for 5 days. So I'll write this as what? T plus 2, yes. And this is 21. So this will be 1x plus 2y is equal to 27. Sorry, 21. Let's make it neat. Yes. That's my equation 2. So now we are looking at elimination method. To do so, we have to look at the coefficients and the constant and choose the easiest one. 1 and 1 is the easiest one. And then we are looking at adding if finding the HCF or sorry LCM, that's 1. Multiplying with stuff not required. And then at last we have to decide if we need to add, if not subtract. So if I add this 2, this won't get eliminated, so we need to subtract. So we have 1x plus 4y is equal to 27. 1x plus 2y is equal to plus 21. So all these are plus. So we need to convert this to minus. Simple reason being we are subtracting equation 2. This gets cancelled and we have plus 2y is equal to this is 16. Sorry, my bad. 6. So we have divided by 2 both the sides. Y is equal to 3. Okay, so per day you are getting charged rupees 3. Now the first 3 days we need to find that. To do so, we can substitute y in equation 2. So we have 1x plus 2 into 3 being equal to 21. So 1x plus 6 being equal to 21, and we have minus 6 both sides. 1x is equal to 15, and we have the amount. So this entire day, in entirety, this is 15, not per day, in total 15, and you know the charges 333 and so on and so forth. So we ended up with the fixed charge is rupees 15 and charges per day is rupees 3. Let's verify it. Actually, I should have verified before writing. So 15 plus 12, 27, correct? 15 plus 6, 21. So people want to pause, you can pause it now.